Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2101, indicates an ETCS, Electronic Throttle Control System, malfunction in the Honda CRV models from 2011 to 2016. The ETCS plays a critical role in ensuring optimal engine performance by electronically controlling the throttle valve based on input from various sensors. Additionally, this system enhances fuel efficiency and reduces emissions by adjusting the airflow entering the engine. During troubleshooting, it's essential to recognize that the throttle body houses the throttle valve, which is controlled by the ETCS. The throttle body's location varies depending on the engine setup, but is typically situated between the air intake manifold and the air filter. Please be aware of the safety precautions regarding the throttle body, as any improper handling could lead to serious injuries. Before beginning the troubleshooting process, it is advisable to record all relevant snapshot data and freeze frame information, which might assist in identifying the issue. The DTC P2101 signifies an ETCS malfunction, specifically implicating the throttle body as a crucial component of this system. The Electronic Throttle Control System, ETCS, regulates the throttle valve's position to control engine air intake, effectively managing vehicle acceleration. The ETCS malfunction can cause the vehicle to experience reduced power or even enter limp mode. The throttle body, where this critical component is housed, is generally positioned upstream of the intake manifold, making it essential for the engine's air-fuel mix. Improper functioning of the ETCS can lead to unresponsive throttle behavior, impacting overall vehicle drivability. It is important to visually inspect the components around the throttle body area to determine their condition and ensure that they are not obstructed or damaged. Several factors can lead to the DTC P2101 error code. The most common cause is a malfunctioning throttle body, where the throttle valve may not operate smoothly due to dirt buildup or mechanical issues. Wiring issues can also contribute to this DTC. Open or short circuits in the wiring, particularly in the MTR1 and MTR2 lines, can disrupt the signals sent to the Powertrain Control Module, PCM. Poor connections, such as loose terminals between the throttle body and the PCM, can create intermittent communication failures. It's crucial to inspect both the wiring and connections thoroughly, as they are often overlooked in the diagnostic process. Additionally, an outdated PCM software version may cause the system to misfunction. Hence, always verify if the PCM has the latest updates. When a DTC P2101 is present, drivers may experience several noticeable symptoms. A prominent sign is reduced engine power. The vehicle may enter a low-power mode to prevent additional damage. This limp mode is usually accompanied by unresponsive throttle behavior, where pressing the accelerator does not result in expected acceleration. Often, this leads drivers to notice that the vehicle does not respond adequately during merging or acceleration situations. Furthermore, a persistent check engine light is common on the dashboard, alerting the driver about the malfunction. Without addressing these symptoms promptly, further engine performance issues may arise, impacting safety and roadway mobility. Conducting timely diagnostics using an HDS, Honda Diagnostic System, can help pinpoint the root of the problem. In the first step of troubleshooting the DTC P2101, begin by turning the ignition switch to the on position. This action powers up the vehicle's electrical systems without starting the engine. After powering the vehicle, it is crucial to clear the diagnostic trouble codes using the HDS tool, which communicates directly with the vehicle's onboard computer. Following the code clearance, conduct the ETCS test through the HDS's inspection menu. This test evaluates the operational status of the throttle body and records any current or pending trouble codes. Ensure you closely monitor if the P2101 appears in the readout during this process, as this will indicate whether the malfunction has been confirmed or if further diagnostics are needed. Successfully completing this step lays the groundwork for either confirming the issue or moving on to further diagnosis. During the second step, conduct a test drive of the vehicle for several minutes while observing the freeze frame parameters stored prior, such as engine speed, vehicle speed, and accelerator pedal position sensor data. These parameters provide a comparison to current driving conditions, helping to determine if the issue is consistent or intermittent. Once the test drive is complete, use the HDS to scan for any pending or confirmed DTCs again. This process is essential for verifying whether the P2101 code appears once more, indicating a recurring issue with the ETCS. If the DTC is confirmed, it signals that the fault may have temporarily reset, necessitating deeper diagnostics. However, if the DTC does not return, it may indicate a temporary fault, warranting further inspection of the electrical connections for potential looseness or corrosion. In this step, start by turning the ignition switch to the lock position, cutting off power to the vehicle systems. Next, disconnect the intake air duct from the throttle body. This disconnection allows for improved access to the throttle components, enabling thorough checks while ensuring that the system is de-energized for safety. Then, turn the ignition back to the on position to enable the HDS for further testing. Perform the ETCS test in the inspection menu while visually checking the throttle valve's operational smoothness. This step is critical, as a throttle valve that operates smoothly signifies that the mechanical aspect is functioning correctly, while stiffness or erratic behavior may indicate a need for cleaning or replacement of the throttle body. Cleaning the throttle body can often resolve operation issues, and if problems persist, a replacement may be necessary. The fourth step entails checking for any open wires in the MTR1 and MTR2 lines that connect the throttle body to the PCM. Firstly, turn the ignition switch back to the lock position for safety. Then, using the HDS, jump the SCS service check signal line to allow continuity testing between the throttle body and the PCM. Next, you'll want to disconnect the PCM connector C, 49P, and the throttle body 6P connector. To proceed, connect the jumper wire between terminal A and terminal B in the throttle body 6P connector, facilitating a stress test for electrical signals. After connecting, check for continuity between the designated test points at the PCM connector, indicating a complete circuit without interruptions. If continuity is confirmed, it suggests that the wiring is intact, while lack of continuity indicates a need for repairs to the MTR1 or MTR2 lines. For the fifth step, conduct an internal circuit check of the throttle body by measuring the resistance between specific test points. First, ensure that the ignition is in the lock position and both the PCM connector C, 49P, and throttle body 6P connector are disconnected from their terminals. Utilize a multimeter to measure the resistance across the throttle body 6P connector. A resistance reading of around 1.0 kiloohm or above indicates that the internal circuit is functioning properly. However, if the resistance is lower, it's likely that the throttle body has internal damage and requires replacement. A thorough inspection should guide you here. After replacing the throttle body, it is essential to verify its functionality again to ensure the DTC P2101 is cleared. If the circuit checks out, but issues persist, it may be necessary to check for the latest PCM software updates or consider substituting a known good PCM as further troubleshooting. In this concluding repair verification step, ensure all connectors are securely reconnected following repairs or component replacements. It's crucial to maintain proper connectivity, as overlooked connections can create additional malfunctions. After confirming all components are connected, utilize the HDS to reset the powertrain control module, PCM, preparing it for recalibration to new operating conditions. Once the PCM is reset, perform a PCM idle learn procedure, allowing the vehicle systems to recalibrate and adapt to any changes made during repairs. This procedure involves running the vehicle in idle conditions for a specific period, enabling the ECM, engine control module, to learn the new baseline operational parameters. Following the idle learn, take the vehicle for a test drive again to validate the repair. Lastly, scan for any new or recurring DTCs to ensure that the issue has been effectively resolved. After successfully addressing the issues associated with DTC P2101, preventing future occurrences is key. Regular maintenance is crucial to the longevity and reliability of the ETCS. Begin with the routine cleaning of the throttle body, as accumulated dirt and carbon deposits can significantly impair its function over time. Additionally, a periodic inspection of the wiring connections is vital, specifically looking for frays, corrosion, or disconnections that might compromise signal integrity. Ensuring that the PCM operates with the most current software is another important preventive measure. Staying up to date helps the vehicle systems function efficiently, especially with evolving vehicle technologies. Following these preventive steps can significantly reduce the chances of encountering similar issues in the future, leading to a smoother, more reliable driving experience. In conclusion, understanding the DTC P2101's implications is vital for maintaining your Honda CRV from 2011 to 2016. The diagnostic process highlights the complexity of the ETCS and its dependence on various components and signals. Thorough inspections of the throttle body, wiring, and PCM are critical in identifying the root cause and performing effective repairs. Regular maintenance practices, such as cleaning the throttle body and ensuring that all connections are secure, can help prevent DTC occurrences in the future. As technology evolves, staying abreast of any necessary software updates for the PCM will ensure optimal vehicle performance. Applying these insights will not only aid in resolving the current DTC, but also contribute to an overall better driving experience. Please like and subscribe to the channel. See you next time.